All right, so here in 2019, problem number 4, no calculator question. And it looks like we have a little diagram. The diameter is 2 feet, the height is h feet, and it looks maybe we're finding the area of this or the volume of this thing or something, but let's go ahead and read through. A cylindrical barrel with a diameter of 2 feet contains collected rainwater as shown in the figure above. The water drains out through a valve not shown. Okay, so it's flowing out through a valve not shown, and at the bottom of the barrel. The rate of change of the height h of the barrel, water in the barrel, with respect to time is modeled by that guy right there, right? And just by looking at this, the way they wrote that, that makes me think it is a dy over dx problem, like I have it labeled up above, okay? And even though it's dh over dt, but like I said before, and I've kind of warned, is it's dy over dx, but this is a y value. That's an output, which is a little bit strange, because normally a slope you would hope would be written in terms of x, the input, where h is measured in feet, so we have feet per second. Okay, and they also give us the formula for the volume of a cylinder. That's nice of them. All right, so we have 3 parts. Hopefully it won't take too long. Find the rate of change of the volume of water in the barrel with respect to time. Taking derivatives with respect to time, so everything gets a prime on it, right? When the height of the water is 4 feet, indicate units of measure. Okay, what am I supposed to do? Find the rate of change of the volume of water. Where does it talk about volume anywhere? It looks like right here. And this is a little scary because it has an R and an H, so it looks like there's going to be, I don't want to have to do the product rule here. So I'm going to go ahead and start with V equals pi R squared H. And luckily, this is not a cone, it's just a cylinder, because the radius here, the radius is a constant. So we can go ahead and plug it in right now versus something that is a actual variable. The radius is just 1. So in that case, the radius, let's plug it in right now. We really just have volume is equal to pi h. That's it, right? And we want to find not the volume, we want to find the rate of change of the volume. So we're going to go ahead and take the derivative of v, which is in this case, with respect to time, dv over dt, say v prime, equals, and the derivative of this guy is going to be pi h prime. Pi, and h prime is really just dh over dt, right? But I'm going to h prime. Okay. That is this thing, right? So I'm going to go ahead and substitute this piece in, because all we really know, they didn't tell me the speed of the height, they just told me that it was 4 feet. The height was 4 feet. H equals 4. Right? So I'm going to go ahead and substitute this guy in. So we have v prime equals pi and negative 1/10 square root of h. Okay, so to find the volume, we multiply pi times negative 1/10 times, in this case, 4. And what is that going to give us? It's going to give us 4/10 and the square root of 4, so it's going to be 2/10. So v prime equals, there's going to be a negative there, there's going to be a pi here, and I said 2/10 and 2/10, 2 over 10, they're both even, so it's going to be 1 over 5. And since they had units on this problem, I definitely want to include those as well. So this is the speed of the volume, which is going to be measured in seconds and feet. So feet per second. Box that answer up. Okay. Before, we've had cones that are dripping blood. We've had all kinds of different problems, but this one was a little bit easier because we only really had h as a variable and we had v as a variable. Okay, let's try the next part. When the height of the water is 3 feet, so when it's maybe around here, or maybe this is 3 feet, when the height of the water is 3 feet, is the rate of change of the height of the water with respect to time increasing or decreasing? Explain your reasoning. So this is the part that I always slow down on. These problems make me a little nervous when they're not asking about speed, they're asking about when is the height of the water is 3 feet. Is the rate of change of the height of the water with respect to time increasing or decreasing? So what are they asking me? Are they asking me to take the derivative, take the second derivative? Looks like we already have the first derivative right here. Let's reread it one more time just to make sure that we're actually answering the question. We know they want 3 feet of water. Okay, that's not the question. Is the rate of change of the height of water with respect to time? They're saying, is the rate of change increasing or decreasing? Right? So this is already telling me they're talking about the first derivative, and then they want to know if the first derivative is increasing or decreasing. So I'm pretty sure they just want me to look at the second derivative. Okay? So the derivative of this guy with respect to time, the derivative of h prime is h double prime equals, and now this is going to be, I guess I should have written the original thing, this is going to be h to the 1/2 power, right? So I have -10, the h to the 1/2 power is going to go out in front, and then the power goes down to -1/2, which is a little bit scary, but that's okay. So it's going to be -1/20th, h to the -1/2 power, and then h prime. All right, whenever you're taking a derivative with respect to time, you get an extra dh over dt or dv over dt or whatever it may be. Okay, so we're only plugging in 3 right here. We're supposed to plug in 3. So this guy is a little bit of an issue. This is the h prime that we knew from before. So I think I'm going to go ahead and resubstitute some of this stuff. Maybe clean that up just a little bit, because -1/20th. And then here I have the square root of h, 1 over the square root of h. That h, this is the square root part, and then that negative pushes it down into the denominator. Okay, and then now we also have h prime, which is times -1/10, and then square root of h there. So really the question is this thing positive or negative? Right? So we're looking at 3. I don't have to actually know what the answer is. I just have to figure out, is this thing, if I plug that in there and that in there, is this thing going to be positive or negative? So I have a negative times a positive times a negative times a positive. And those guys right there make a positive. Therefore, the answer is going to be increasing. If they were asking about the speed of the water, I would have to compare whether this is positive or not, or negative, and then whether this was positive or not. But this just means, yeah, of course the water is going down, and the velocity is negative, because the water is going down. Down, we would assume, was negative. But really the question is really just, is it increasing or decreasing? And the rate of change is increasing, although it still is negative. So because the answer is increasing, and it's because that was positive. Okay. All right, here we have our last part. Like I said, B, these always throw me off a little bit, so I definitely try to slow down through here. If they say the word speed or they say increasing or decreasing, I just am a little careful to make sure that I actually answer the question they want, not the question that I assume they were asking. So, last part. At time t equals 0 seconds, the height of the water is 5 feet. Use separation of variables to find the expression. Okay, so this is the question I knew was going to occur. Anytime you see one of these dy over dx problems, they typically always ask you to separate eventually and then integrate with your plus c, solve for the plus c. A lot of times on these problems, they ask you to use an estimate with a line, so you have a slope and you have a point. Where's the point? You have a slope and you have a point that they just gave you. So anyways, this is where they're asking you to use separation of variables to integrate. So the first thing I'm going to write down is dh over dt equals -1/10, and then we have h to the 1/2 power. Okay, and we have a coordinate. It is 0, 5 that they're giving us. Right, so let's go ahead and separate. It looks like I can take this guy and move it down to the denominator, which would really be h to the -1/2 dh. I'm going to leave the -1/10 there. -1/10 is going to stay, And this guy I'm going to send to the other side, dt. So since it was in a denominator there, it's in a numerator here. Since that's in a numerator there, it would be in a denominator, but I just know I want to use the reverse power rule, so I'm kind of anticipating. If you need to do another step, then go ahead and break that into 2 steps. All right, so I separated the variables. That's hopefully worth a point. Now let's go ahead and integrate. This is going to go up in power, so it's going to be h to the 1/2, and then divide by 1/2 really means multiply by 2, equals, and integrate this is going to be pretty easy, -1 divided by 10 with a t plus c. And like I said, I just normally put the plus c on this side, not on both sides, even though you technically can. From here, let's go ahead and plug in our 0, 5. So I always plug in right away. You could start manipulating things, but the answer they're going to have on the answer key is going to be for that c value the way it is written right now. So 5 goes in that spot. That's a little bit ugly. That's going to be 2 and then the square root of 5 equals, I have -1/10, and I have to plug in 0. At least that was nice. So c is 2/5. 2 square root 5, not 2/5. C is equal to 2 square root 5. And I think they wanted one more thing. They wanted me to find my expression for h in terms of t. So that means they want me to clean this thing up and make it look nice. So I'm going to go ahead and put my 2 square root 5 in there just to save a little bit of room. So they want me to divide everything by 2 and then square the whole entire thing, essentially. So if I divide everything by 2, I'm going to get h to the 1/2 equals, divide this by 2, -1/20 t, divide that by 2, plus the square root of 5, and then square the whole thing, and so I get h is equal to square the whole thing. Don't even make it look pretty. Just say that you are squaring the whole thing. And they were asking specifically for an expression, so I'm going to go ahead and box up that answer right there. If they asked for an equation, I would include the h. Okay. All right, so definitely a pretty common question. I don't think it's as common to have some sort of volume or this first part, but they always like to ask, write the equation of a line and then also separation